Hey everybody, so today we're going to start the fourth section of Unit 7, which is parallel lines and proportional parts. So yeah, we're going to jump right in. So really the main idea is here we're going to be able to look at parallel lines within triangles and what it does in terms of creation of proportional parts. Alright, so let's check out this first piece here. Oh, let me change that. There we go. Okay. So there's a bunch of theorems we're going to review, and I'll give you some examples, and that should help you with the exercises we do in this section. So the first one tells us that, and this is the triangle proportionality theorem, if a line is parallel to one side of a triangle and intersects with two other sides, then it divides the sides into segments of proportionate lengths. What does that mean? Well, let's look right here. So you can see here we have a parallel line segment that is connecting these two sides of this triangle. And what it does, it creates these two proportionate relationships. So for example, AB is going to be the blue. So this isn't going to be that different from the previous section if we think of it this way. AC will be the red, AE will be the blue, and AD will be the red. So we could have AB over AC, right, is equal to AE over AD. Okay? And let's use it down here. So we'll do blue over red. So XB over AB. So we're going to say 10.5 over 4. Ooh, what am I doing? 10.5. Let's try that again. Over 4 equals, and here's the blue, and here's our red. So x over 6. We can solve that. So let's go ahead and solve that. So we're going to cross multiply here. Let's cross multiply. We could just multiply by 6, but we'll do that instead. So 4 times x is 4x. 10.5 times 6, I think that's 13, but let's just double check. No, what am I doing? 13. Give me a break. Right? That's going to be 63, but let's just double check. 10.5 times 6, 63. Yep. But it's always good to check when you're doing these. You don't want to make an arithmetic mistake here. 63. We're going to divide by 4. And x will equal 63 divided by 4, 15 3/4. Okay, there we go. So next one. Corollary, I love that word. Congruent parts of parallel lines. So if 3 or more parallel lines are cut off by congruent segments on one transversal, then they cut off congruent segments in every transversal. So here we have a transversal, and here we have another transversal. So it's telling us that these congruent segments on this line segment, by line segment I mean AC, means that these two would also be congruent. It means EF and FG would be congruent. So check this out. Let's see. So in essence, if we know that these are congruent, that means these other pairs are going to be congruent. So an example of that would be if AB is congruent to BC, then EF is congruent to FG. Okay. Well, we can set these equal to each other and solve for x and y. So we can say 3x minus 7 equals x plus 5. And we can also say 9y minus 2 equals 6y plus 4. we know these are congruent because we're told with the markings here. Alright, so we're going to solve each one of these equations algebraically. So we're going to subtract x from both sides. So 3x minus x is 2x. Let's zoom in a little more so you can see a little better. There we go. So 2x minus 7 equals 5. We're going to then add 7 to both sides. And then 2x is equal to 12. And we're going to divide by 2. And x will be equal to 6. Okay. Here we're going to subtract 6y. Subtract 6y. 9y minus 6y is going to be 3y minus 2 equals 4. We're going to add 2 to both sides. Oh, what's not? Yeah, there we go. And 3y equals 6. Divide by our coefficient, which is 3. And y will be equal to 2. There we go. Oh, I totally cut ourselves off. There we go. Alright, let's see the next one. I think I did these out of order. That's okay though. Doesn't really matter. A few more here. Hopefully, yeah, I think I can finish this in time. Alright, so we got proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, they cut off the transversals proportionally. Ah, this is another good one. So here's a good example of this. So it's creating a bunch of proportionate relationships here. So let's go with this one, I guess. So if these are parallel and these transversals cross here, right? And sorry, if they yeah, let me make sure this is right. If 3 or more, yeah. So these transversals are going to have some proportionate relationships. So for example, AB over BC would be equal to EF over FG. That's one example of some of the proportionate relationships that would pop up there. Let's check out this example down here. So maps in the figure, large maple and nutshad streets are all parallel. So these streets are parallel. Let's go ahead and mark that. Okay. The figure shows the distances between the city blocks. Find X. Alright, so these are both transversals, this segment, this line, and there's some proportionate relationships. So, yeah, we can go ahead and do it this way. So we're going to say blue over red. So 16 over X will be equal to blue over red. So 13 over 26. I'm going to simplify that. I know that's a half, so I'm going to say 16 over X is equal to 1/2. Now we're going to cross multiply. So we're going to say 1 times X is X, 2 times 16 is 32. And there's no units, so X is 32. Pretty straightforward. Cool. Alright, let's see. What am I going to do? Let's do this one. Alright, so converse of triangle proportionality theorem. If a line intersects 2 sides of a triangle and separates the sides into proportionate corresponding segments, then the line is... Okay, so basically we're saying the reverse of what we did before. So if the proportionate relationship exists, that means these are parallel. That's essentially what that means. So I guess we're going to say... We'll do it this way, I guess. Let's say if... let's say... Blue, I just really like using these colors. I think it makes it a lot easier. So if, let's say EB over AB is equal to, we'll do the other ones here, blue over red, BD over BCB, then that means these are parallel. So ED is parallel to AC. Okay, that's what that means. So here we go. In triangle DEF, DH is 18. So DH is 18. HE is 36. Okay. DG is 1/2 GF. So we're going to call GF X. And this will be 1/2 that. So this will be 1/2 X. Oh, that one's not great. Alright, so yeah, GF is X and then DG is 1/2 that. Okay. So we're going to see if this works. If these are proportionate, then we know these are parallel. Okay, so we're going to set this up. So we're going to say blue. Now if you do this, there's a conceptual way to do this. It makes it actually a lot easier, but I'm not going to do that just yet because that makes things a little too easy. Alright, so blue over red, blue over red. So 18 over 36 is equal to we'll say 0.5x over x. And we're going to say, we're going to make this into 1/2. We can simplify that. Yeah. So 1/2 equals 0.5x over x. We're going to cross multiply. So x equals, this is going to equal x. So it's a true statement. So these do equal each other. This is going to be proportionate. And think of it this way too. When I'm saying doing this logically, all right, so this is half of that, right? This is half of that. They have the same proportionate relationship. You can actually solve this without even doing any sort of algebra here. We got a true statement by working it all out. But when you look at this, you say, okay, this says this is half of that value. Well, this is half of that value too. So you could actually say yes because of that without even doing it algebraically. But it's good to be able to show it too. So, last one. Triangle midsegment theorem. All right, the midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 that length. Sorry, length of that side. Now, I don't know if you guys know this. We haven't learned this in class yet. So a midsegment, just so we remember, midsegment. It's a segment, line segment, connecting two midpoints of two sides, I should say the midpoints of two sides of a triangle. So because we can see here that this is the midpoint of this segment and this is the midpoint of this segment, you can tell because of the congruent marks here. This would be the midsegment. All right, so let me read that again because I probably should have said that before we even talked about a midsegment. Most of you probably don't know what a midsegment is. Now you do though. A midsegment of a triangle is parallel to one side of that triangle. Let me read that again. A midsegment of a triangle is parallel to one side of the triangle and its length is 1/2 that side. Okay. That's what we know about midsegment. I guess they're just telling us about that. Forgot about that. For example, if J and K are midpoints of FH and HG, then, respectively, JK has to be parallel to this, and this is half the length of that. In other words, a midsegment is going to be half the length and parallel to the third side. It's a much easier way of saying that. I love how theorems and corollaries make things sound way more complicated than they are. So for example, if this was 20 meters, this would be 10 meters, and it'd be parallel to it. That's the English version of it. All right, in the figure, DE and EF, these line segments are typoed. DE and EF are midsegments of ABC. Ah, interesting. We have two midsegments. Okay. And find AB, FE, and the measure of angle AFE. All right, well, let's see here. So this is 18. We're telling this is the midsegment, so that means these two are congruent. So that means they're going to cut 18 in half. So this is going to be 9, and this is going to be 9. Okay. Let's see. What else we got? 1 second. So what we do know already is that this is the midsegment of this. So FE is the midsegment. Right, that means it's half the length of BC. So FE is half of BC. This is a confusing problem because you have two midsegments. So instead of one midsegment, you have your brain's trying to process both these at the same time. So it can be really confusing the first time you look at it. So FE will be half. So try to ignore this if you can. FE is going to be half the length of this. If you think of it this way, you can only see one midsegment. It's actually not that awful, but when you see both, it's hard to process it. And then you have this angle thrown in the middle of it. So it's a tricky problem when you first look at it. So FE will be half the length of BC. Well, BC is 18. Therefore, we know this is 9. So we have FE. FE is 9. Okay. What else do we need to find? We need to find AB. So AB is here. We need to find out what that is. Okay, now it's starting to make sense. So now try to ignore this one. This midsegment is going to be half the length of this. So we're gonna write that down. ED is half of AB. So if ED is half of AB, that means this is double that. So 5 times 2 is 10. So AB is 10. So AB is 10. Okay. The last part we're looking for is the measure of angle AFE, which is here. We're looking for that angle. Interesting. Well, let's see here. AFE. So this part right here actually talks about something we learned way back when. So these are parallel to each other because they're midsegments. This midsegment is parallel to that. So if you extend that, right? Think of this as a transversal. These are alternate interior angles. This would be the same as that. So that's why it's 87. So, okay. Challenging problem. Not the best problem to do right after learning it, that's for sure. But it's a good problem. This is something I think that will make a lot more sense once you get more familiar with this. This is probably like learning how to play baseball and then suddenly being thrown into a major league game. We're going to this problem. But yeah, it'll make more sense once you try some examples, so don't worry too much. Alright, so those are all the examples we have for this note section here. We're going to be having some more exercises we're going to do with these and some practice, and I'll be posting some more videos with a lot more examples. So we'll be probably flying through this pretty quickly, I think. Alright, thanks guys. Talk to you soon.